Let's move to the next talk. The title of the next talk is Pisces Updates for Integrating CSS3.0-like database tables and files into OpsPy workflows. It falls under the theme 3.1. The talk is from Christine Gammons from Los Alamos National Laboratory. Please play the pre-recorded talk.
Hello everyone, my name is Christine Gammons. Today I'm going to be giving a presentation on the updates Jonathan, Brady, and I have made to Pisces, specifically for integrating CSS 3.0 like tables and files into ObsPy workflows. I'd like to start off by noting that going forward, I will be using the term CSS3 databases or database tables to more broadly refer to CSS 3.0, KB Core, and Antelope database tables based off those schemas. Those are the three currently supported by Pisces. I'd like to note many institutions use an expanded schema that includes many of these tables, such as site, origin, event, etc. But Pisces doesn't support every single table in those schemas. Pisces was open sourced in 2014 as a library specifically designed to integrate CSS3 databases into Python codes by defining the tables and columns into objects understood by SQL Alchemy, another open source library designed to interact with databases in general. Pisces also supports the translation of the data and metadata stored in CSS3 databases into ObsPy objects, specifically for integration into Python workflows. Currently, ObsPy streams and response objects are supported and catalog inventory objects are in development. I was hoping to have those done by the time of this presentation, but everything takes longer than you hope it will. Functionality to convert instrument responses into response objects was added last year and will be the first thing I talk about. Another note I'd like to start with is how I will be referring to instrument response files for the remainder of this presentation. Specifically, I will frequently use the term PASFIR file or PASFIR response to broadly mean instrument response files, including FAT files that are formatted according to the specification defined in the appendix of the 2002 IDC processing manual. This is how we refer to them at Los Alamos. That may not be the case anywhere, so I wanted to make that clear to everyone. On this slide, the figure, you can see a truncated example file. There's some commented header information and then a series of defined stages. The specification supports pole zeros or PAS phases, finite amplitude response or FIR phases, infinite impulse response IIR, and frequency amplitude phase FAP. The file itself contains the shape of the curve, but the actual scaling is of the response for each channel or sensor is stored in the database as the calibration in calib at period in calper as defined in the instrument table, or the calib at period calper in the WOOF disk table. I'd also like to note that many of these files that exist have a group delay stage. However, this stage isn't defined in the 2002 IDC processing manual and has not been added into the Pisces response conversion, though I have plans to do so soon. Since ObsPy is the main Python package used by the seismological community, the goal is to translate PASFIR files and their corresponding database fields into ObsPy response objects, which are a combination of different stage objects. Specifically, PAS stages translate into pole zeros response stages, FIR and IIR translate to coefficient types response phases, and FAP stages into response list response stages, which contain a list of response list element objects, which each contain a single frequency, amplitude, and phase triplet. The instrument sensitivity object is the stage 0 information as defined in the SEED manual, and it includes the total scaling and unit information for the entire response. So it is a combination of all of the gains, normalizations, and the total units, typically from ground motion to counts, for the entirety of the stage. Here I just wanted to show the workflow converting these files, as well as include some technical notes and caveats on the process. You'll note that there is some orange color added to there. I tried to keep the coloring across various workflow diagrams consistent across the slides. That relates to a later slide. The inputs here into the process are shown in green. The dir and the d file in the instrument table give the file location, and this file path, as well as the calib and calper, or from the instrument table, the incalib and incalper, are all response into the read passphere function. You can also set the ground motions to output into either meters, nanometers, or pascals. Typically, the database spec for the scaling information is all in nanometers in displacement in CSS3 like databases, but I wanted to give the option to output in meters as well. You can also see that once you have the file that I show the workflow into the D file location, the inputs into the response object conversion for the read passphere function, and then below that you see the actual response object and what it looks like for this file. Again, I used station A and MO, the station shown in the truncated example file in a previous slide. The sensitivities from all stages are combined into the calibration value in the database. I cannot break them out by stage. What this means is that I set the gain for all stages after stage 1 to 1. And then I set the gain of the first stage, typically pole 0 or FAT, but not always, to the total sensitivity value, and then set that in the instrument sensitivity object or stage 0 object. As a result of these assumptions I have to make, because I can't break them out, you cannot pull out individual stations as independent or truthful on their own. They really need to be left as the entirety of the response object in order to be accurate. I also implemented a passphere file writer that will take a single station XML input, and it will output passphere files for every single response contained in the station XML object, as well as fixed width formatted flat files for the corresponding instrument and sensor tables based on the information in that station XML. Because one station XML file can contain a large number of responses, the file naming for these are fixed. I wanted to note that it would be on the user to change that, as well as to adjust the ID numbers from the flat files if you are going to upload those into a database. But here you can see where the green text box, that is the inventory, is input into this XML to passphere function. With some available information about the working directory path and whether you want to write out the tables and what the frequency, all of these would be calculated that if you want it to be consistent or you want to be different than the frequency for each response in the station XML file. One more note I'd like to make about this slide as well as the last. This is implemented and available through Pisces now. But the API is subject to change. I'm still making some updates, adding some functionality, and some terminology may change. So if you go to use it, just keep that in mind, although there is a deprecation warning whenever you use these functions. Here I wanted to show a comparison of response curves to indicate that the passphere reader works as expected. The graph or the figure on the right shows the response curve from the station XML file for station A and MO from Iris. And the figure on the left shows the response from the PASFIR file in our database. In this case, the file in our database was converted from the station XML from Iris, but that was done by a different researcher using a different set of codes, giving a little bit of independence to show that this does take the file and convert it correctly. That being said, I do have a note that I had to apply the phase correction manually because, again, I have not implemented the group delay stage, though that is on the list to do this next year, assuming everything goes according to plan. But you can see from the two comparisons that the response curves are effectively the same. The reader will convert the PASFIR file to an OBSPy object, and this was plotted using the response.plot from OBSPy. And then for the last slide related to the instrument response functionality in Pisces, I just wanted to show that the OBSPy remove response works with this object, and it does produce the same deconvolved waveform effectively. This is from a magnitude 6.5 earthquake in Nevada on May 15th, 2020, as recorded at ANMO. The top waveform is just the response deconvolved in displacement from Iris, and then below that shows the response, the deconvolved waveform using the PASFIR response at LANL overlaid on top of the Iris waveform, and there's effectively no difference, though if you were to scroll in, you may see some small differences, but they are effectively identical. The next two slides show the in-development work on the inventory and catalog objects. Figures on both slides show a rough workflow for translating CSS3 database tables into these objects, which are structured around the FDSN specification. As a result, some adjustments have to be made. For the inventory object specifically, if a network code is not provided for each station, the network is set to a double underscore, which I chose because the double underscore does not conflict with any existing network codes, and if a user exports waveforms or station XML files based on the ID, the file name will not start with a period and become a hidden file. Also, there are no location codes, as they are not contained. Location codes are not contained in the CSS3 family of schemas. Pisces will convert what is in the database as it is in the database. Particularly, for example, around location codes, we at LANL often append the location code to the channel to get around that limitation, and as a result, this is how the location code will appear in the inventory object. Catalog objects have fewer adjustments as a result of differences between QuakeML and CSS3 specifications, but some of the terminology is different. For example, a catalog object pick is equivalent to a CSS3 arrival, and a catalog arrival is equivalent to a CSS3 ASOC field. CSS3 also has a different set of event types and associated codes, so a translation layer is added within Pisces to ensure the output is consistent with the FDSN specifications. To summarize this presentation, Pisces is being actively updated and maintained. The recent additions include read and write capabilities for instrument response files. Inventory and catalog support are in development. We also have some longer-term plans that are not shown here, including improving the Pisces backend to be more agnostic, to include more agnostic data typing using Libra, another LANL data management package open sourced in 2024 that adds in support for multiple schemas based on some definition of those schemas within tables. And then lastly, we are looking to add web service interfacing support for schemas supported by Pisces, essentially KB core web services similar to an FDSN web services, but supporting the KB core and CSS3 family specifications. Thank you. Let me know if you have any questions.
Thank you.
Thank you very much, Christine. Christine, you are online, right?
Yes, I am here.
Thank you so much for joining us, and thank you for this amazing work that you just presented. We're waiting for questions from the audience. One question from our side is, could you please tell us about the benefit of this improvement? What does it mean in terms of time saving and so on?
It'll let researchers go directly from database tables to these OpsPy objects, since that is kind of the primary Python, open source Python package seismologists use. The idea is that once this piece is complete, it'll go into a larger function that you can treat similar to an FDSN web services, where you can put in station information and it'll pop out an inventory, and you don't have to go through and extract all of the information from the query from the database yourself.
Very good, very good. Thank you for that. In addition, we got already some questions from the audience. I will read it for you.
Mm-hmm.
So a member of the audience thanks you for the presentation. And this person says, while the group delay for FIR stage is relatively straightforward, how would you estimate the group delay for the PAZ stage when the phase response is nonlinear?
I don't have a good answer for that. Right now, that is a bit beyond the scope of what I'm trying to do. I am trying to convert files exactly as I get them, because there's not a defined spec that I can find. If someone has one, please send it to me. For the group delay, I have to go through and find enough files and make sure that the delay is behaving the way I think it is. Because if you go through the seed manual, many times the digitizer will anticipate the delay, so it'll actually timestamp the samples to account for it, and I want to make sure everything is behaving the way I believe it to be. So without a defined spec right now, I just need to go through and find enough files and test it and make sure it does what I think it does. In terms of estimating it from the past stage, that would be a much further out question beyond just getting these converted directly.
Well, I mean, for sure, people will contact you because we are being flooded by questions about your presentation.
Okay.
So, Brian, would you like to read another one?
Yeah, we have another question from the audience. Thanks, Christine, for your presentation. That's within the question. And providing an important code allowing to convert CSS formatted data to the FDSN standards. Could you say something about the waveform functionality within PySys?
So right now, the waveform functionality is the most complete. I was hoping to have some of this more done by this presentation, but time being what it is, that will, if you know how to format set up the Pisces tables and kind of format the queries, there is a woof disk to trace function that for every query that comes out of that woof disk table, it will create a trace in a stream for every woof disk entry. The nice thing about the inventory stuff is that once all of that is complete, it'll also be able to potentially grab responses or build an inventory so those can be directly attached using the existing OpsPy functionality.
Thanks very much.
Thank you, Chris. One final question from my side, and then what we will do is we will send you all the questions that we're getting so you can review them. So the question, I'm a passionate myself about data, and the question is about database. So does PySys include any consistency check to spot possible errors in the databases?
Not really. That is a recognized need. We are working on a different data management package that we've open sourced called Libra that we are imagining will have some QC plugins that can do some basic checks, but we are still in the planning stages around that, and I can't make a guess exactly when that will release. Although Libra, which is a schema manager
type package where if you put in the schema, the defined tables in a specific format, it will be able to dynamically create the SQL Alchemy ORM objects for that schema, like Pisces does for CSS3, but Pisces currently has it hard-coded under the hood versus doing it dynamically.
Fascinating. Everybody who has sent a question online, we say thank you. You all can access Christine's presentation online. And what we will do also is that there you can have all your, you can have Christine's email, and we'll forward to Christine all these questions. So Christine, thank you very much for your time. Thank you very much for your contribution and for being here today with us.
Thank you. Happy to do so.
Thank you so much.